Today we're going to talk about how to sketch the graph of a story problem. To complete this problem, we'll pick out key pieces of information from our story and then sketch a graph that represents the change in our variable, temperature, as a function of time. And in this particular problem, we've been told that the temperature of water on a hot stove depends on how long the stove has been on. We've been asked to draw a graph of T, which stands for temperature, as a function of time that has elapsed since the burner was turned on. The description we've been given is that the initial temperature of the water is room temperature. Then, when the stove is turned on, the temperature of the water increases gradually until it reaches a boil, where the temperature remains constant. And then at some point, the temperature is turned down and the water temperature decreases quickly to a simmer, where it remains until the pot is dumped out. So with these kind of problems, we're given a short story that describes how the temperature fluctuates as a function of time, and we're asked to provide a rough sketch of what the graph of the temperature would look like over time. So what we can say is that we have an XY coordinate system here, and we're talking about temperature as a function of time. So if we indicate temperature with a capital T, we'll say that our y-axis is temperature, and our temperature will fluctuate up and down as a function of time t, which we'll denote with a lowercase t. Now we just have to follow the story that describes how the temperature changes over time. So we've been told that the initial temperature is about room temperature. So as a function of time, the initial temperature or the initial time would be 0, right? So at time 0 here, or where t, lowercase t, is equal to 0, the initial temperature is room temperature, and maybe we'll just say that that's something average like this. We never have to get very precise with these generalized graphs, but we'll call this room temperature, and we could maybe even indicate here that this is room temperature. Then we've been told that when the stove is turned on, the temperature increases gradually. So we'll say that the stove is turned on almost immediately, and the temperature will increase gradually as a function of time. So maybe this is gradual until it gets to boiling, and maybe we can call this boiling here. So we'll call this boiling. So it increases gradually until it gets to a boiling point, at which point it remains fairly steady at boiling. It remains fairly steady for some period of time until eventually we turn the temperature down. So you can see that we started at room temperature, we've increased gradually, and now we have this plateau here at boiling. At some point the stove gets turned down, at which point the temperature decreases quickly and remains at a simmer. Well, a simmer would be slightly above room temperature, so we can show decreasing quickly and then remaining in a simmer. So we can plateau at a simmer here, and the temperature remains at a simmer until the water is dumped out, you could say. So we'll call this temperature here at a simmer. And if we wanted to label different parts of our graph here, we could do so. We could call this here, this part, boiling, and we could call this part here a simmer if we wanted to be thorough about labeling the different parts of our graph. But essentially this is all we've been asked to do. Given this story problem here, we're asked to just draw a graph that models what the temperature does as a function of time. So we can see that as time progresses in this direction, more and more time passes, this is what happens to the temperature.